Hey everyone, this is Alex, and I'm here to demonstrate a project that I've been working on for a while. If you've noticed, if you've seen other videos on my channel before, you've noticed that I had a kind of more rudimentary version of this AI. Um, I've done a lot of work on it and sort of learned a lot more about Pokemon, and I kind of tore it down and then rebuilt it. And it's something I've been working on for a while, and I think it's kind of gotten to the point where I can make a video update and then do some updates from here, um, and just kind of keep you guys updated with the project. So if you're interested in this project, definitely hit the subscribe button, and you can get some updates from me. Also, you can follow me on Twitter at Alex Wennerberg, just my name, AlexWennennerberg. And I probably won't talk about this, but you can keep updated on my life in general. So uh, let's start. So without further ado, let's talk about how this works. So this is an emulator called VBA, Visual Boy Advance Re-Recording. And what it does is you can play Game Boy Advance games, and you can also run basic Lua scripts. And the Lua scripts, Lua is just like a scripting programming language, and you can use the Lua script to both input buttons into the game and also read each memory location, or read the memory of the game in order to get information about the player. So okay, let's go. Let's talk about the RAM. So the way that any Game Boy game works is there's the ROM and the RAM. The ROM is the fixed memory, which is information that doesn't change. For example, information about the Pokemon, information about what each tile looks like, information like what each move does, and so on and so forth. The RAM is information that changes. So with the location of the player, the location of maybe people who are walking around, what items you're holding, what Pokemon you've collected, and so on. All that is stored in RAM, which is dynamic memory. So each memory location, as you can see here, has a certain value, and you're like, that doesn't make any sense. Fortunately, there is someone who did a deconstruction of Pokemon Red, which is basically the same as Pokemon Blue, and they found out what each memory address means in the game, what its in-game meaning is. And so I'll link that in the description, and I kind of have been using that to help the game get information from, or the script get information from the game. So let's talk about how the map functions. So each tile so each coordinate has a certain tile at that coordinate, and the tile has information embedded within it about what the tile is. So a tile is not just an image. It's not it's not that there's an image here on the screen and then that there is like information at each coordinate. The image and the information about each tile is embedded. And when I say information, I mean whether or not you can walk on the tile, whether it's like a warp tile, whether it's a tree, ocean, and so on and so forth. Things that have certain in-game meanings, like a sign where if you press A, it'll display text, and so on. So that's embedded into the image in this tile object. And so the way that the script works is it reads through, it looks at this screen, and then it will just gather the raw data. So it'll say right here is 4848, tile 3132, and then 3000, 3132, 3000, and so on and so forth. And so it reads that, and then it puts it into a two-dimensional table. And then what it does is, this is something I have to do manually because the way that pointers work, it would be really complicated to actually get that information directly from the ROM. So I just manually input it. It's pretty simple. It takes me a few minutes for each new area. And then I associate each tile with whatever meaning it has, whether you can walk on it, whether it's a ledge, whether it's a door, a warp point, and so on. So it takes raw data, converts that into a map that has a certain meaning. The most important things for this is walkable tiles, non-walkable tiles, and warp tiles. And that's how it's going to actually navigate around the world and start exploring. So that's kind of how it looks at the screen. Let's talk a little more about the world in general. So we have the world is broken up into individual maps. And so this is map like 1 or something like that. I don't remember. Yeah, 1 or 0. And then if you walk here, oh, you're in like map 2, and so on and so forth. You go into a door, you're in map 37, something like that, right? And so there's a bunch of maps, and there's a world that's associated with each map. And so every time I change, every time I go into a warp point, I say, okay, this is a new map. I read the map number, which is something that's stored in memory, and then I look at the map that I see on the screen, and then put that into that. Look at the tiles that I see on the screen, and then store that into the map. And then every time I move, sorry, I'm kind of jumbled here. It's like I know so much about this, but it's hard to sort of convey all the information that you guys might not know about Pokemon, like how it works in memory. So every time I press right, every time I press left, what it does is the coordinate of the player within the map is stored in memory. And so it reads that information. And then whenever that changes, it will say, did it change up, down, left, right? And then it will add the right side, the bottom side, the top side, and so on into the map. And then as I explore, the map gets larger and larger and larger. Like the visible map to the program gets larger and larger. And then it can kind of explore an area. So this map is not actually, because this map is stored in ROM and not RAM, and also I feel like that's kind of maybe disingenuous. It would be to give the computer like access to the ROM when a player wouldn't. You know what I mean? Is it actually has to walk around and then figure out where everything is. Doesn't just know that instinctively, and so. I believe, that brings us to the pathing algorithm. So I'm going to run it and then start talking about how it works. You can see to my right is a debug console. It's not very well written. It's kind of well written, but you probably don't really understand what it means. It's not really important, so don't worry about it. So let's talk about what it's doing. It's using what's called a breadth-first pathing algorithm, which is basically a way to get from point A to point B as quickly as possible. And so you may wonder, well, if it's just exploring, what's point A and what's point B? I'm going to pause this for a second before it does a battle. Well, point A, again, this is a rather sort of rudimentary algorithm. You don't need to, there's no mazes here that are super complicated that are going to need like really tight efficiency. But what it does is point A is where you're at, where the player is at, and then point B is the closest tile that we have that is unknown. So this would be a tile. This isn't just a tile that is the edge of the map. It's a tile that I know exists because we know the size of the map, but is something that is unexplored. And so it's trying to get to the closest unexplored tile. And if it can't do that, that means that we've explored the area 100% because every area has a bounding edge. And for example, if you're inside and you can see that it's just black on all sides and you see the whole room, you're done. Like you can't explore anything else because there's no tiles that you can get to that you haven't seen, that aren't visible on the screen because there's no path outward. I hope that all is pretty clear. And so once that happens, then you leave the area. Then you go through the closest warp, and then try and get to the next area, and then explore that area totally, and then so on and so forth. I'm gonna have it run a battle, which kind of it's pretty simple. Basically, it picks a random move. It always fights. It never runs. It never uses items. The wartortle is very over leveled, so it can do this pretty easy. And then it presses A and then gets out of there. Okay. Yeah, so it's gonna explore here. It's gonna battle. Yeah, so there's some interesting things that I had to do with like figuring out whether it's in a battle or whether it's not in a battle, and so on and so on. That stuff's not as interesting as the like pathing. So yeah, so we do the A star algorithm. We're exploring this area, and then until it says, okay, nothing else I can explore. Let's go into this new area. Here we go. And then, oh, look, this time it just incidentally ended up in a new area. Yeah, it doesn't see ledges right now. So that's why it doesn't ever go over ledges. That's something I'm going to implement. Yep, so it goes here. Oh, we reached a dead end. Let's get out of here. Then we go here. And so this is, the reason it did that sort of backtrack is I'm trying to remember. That's kind of a bug. It's not really a bug, but it's associated with sort of buggy activity. And it's because it will how do I, because the program it's a really, don't worry about it. Anyway, it's kind of something I need to fix on. It's a little bit nuanced. So what it's gonna do is it's gonna we can speed this up and just kind of demonstrate. So, you know, this forest is a little bit more sophisticated of a map. It's not just avoiding objects, and you can see it has no problem navigating. So you notice here it's going to actually backtrack, and that's another thing I don't really know why it does, instead of just going towards the end. But, oh yeah, I should talk about sprites. So sprites are somewhat difficult because their information, because you notice that it creates a path all at once. If you look at the right, I'm going to stop it because this is another buggy part. It creates a big long path, right? And so what it can kind of hang it up is sprites moving around. So that's why it doesn't, is, you know, it creates this path, and then a sprite might be in the way, and I don't really know where the sprite is because I created this path based on unknown information on areas that I can't visibly see on the screen, so I don't know where the like non-player characters are. So what it does is I kind of made a pretty dumb workaround for that, which is it just stops. So it'll, if it hits a sprite, it'll just stop, like, for example, I think right there, and then it will say that it found a sprite. And then next time that it runs, it sort of does the breadth first search and tries to find a path. It'll say, oh, there's a sprite right there, so try and avoid it. So it's not really super sophisticated. It's just, you know, if you run into a sprite, just stop and then refactor or like redo your path with the information that there's a non-player character right in front of you. Again, you know, pretty dumb. So yeah, there was a bug at the end, which yep, and there's kind of a bug right here. Yeah, it really doesn't like this forest because it's kind of unlike most other warps in that you don't really have like a door. Let me stop this. You don't really have like a door that you can go through, right? Because this isn't a door, it's just you're like, that's not a warp, right? Why would I walk there, you know? So that's something I'm gonna have to fix because it just looks like black edge. There's no warp associated with it. But if you go through, obviously it is a warp. So I don't know, I'll figure something out. And then it goes here. And then, yeah, that's basically sort of the extent to what it can do. If I started from the beginning and didn't like interrupt it, it can usually get to Brock's gym. But yeah, so just wanted to give you a quick introduction to this project. I'm gonna open some windows now because it is very hot. uh, yeah, so have fun just kind of watching it explore while I sign off. Yeah, so if you're interested in updates on this project, or have any questions about the details of the implementation, like some of the finer points that are like really boring, leave me a comment, send me a message, tweet at me. Yeah, and if you're interested in keeping updated, I ultimately, so I'll just talk a little bit about kind of the plan that I have for this. I'm going to work on this whenever I really have time, but I think it ultimately what I want to do is get like a genetic algorithm involved, so that instead of just doing really basic motions, it actually can think like as much as a computer can think, and then actually calculate and refine the best way to play the game in order to successfully, and then play it multiple times in order to sort of refine its strategy. I think that'd be fun to watch. That's a long way off, but I don't think it's undoable. I think I could do it. So if you're interested in seeing the progress, subscribe. Immediate issues are probably going to be fixing like the warp stuff, and then just fixing a few bugs, and then after that I could probably fixing like issues with what you've seen can basically get you pretty far in the game, like just with walking around to new places. Like you have to be very smart to play Pokemon, like children play this game. So just with that you can get probably to the third or fourth gym, maybe with a few refinements, like fourth gym or something like that. So that's probably going to be my next step, and then I'll start doing like the genetic algorithm stuff, or like neural network, something like that. Anyway, thank you for listening. Hope you all have a good day, and keep updated. Keep following me.